Okay, so let's see how we got through. We started talking about the quadratic formula, correct? We did not. Is that true? You got? Did I share the song with you? Didn't. Okay. Okay. Okay, that's where we left off. All right. So then we got one thing left to do today, and it's a pretty minor thing, and that's where we're going to introduce the quadratic formula and get a little practice with it. All right. So what's this for? We're solving quadratic equations. We've had a bunch of practice with situations where if I can point to a single variable, I can isolate it with inverse operations, right? We've done that. That's it. That's, to me, those kind are a little bit easier. You don't have to do any factoring. You don't have to use the quadratic formula if you don't want to. We just isolate x when we can point to a single x. But what if we can't point to a single x? What did we do in the past? If we're unable to solve by isolating x, then didn't we put this into standard form? So we got it set equal to 0. And then we tried to factor the left side and use the zero product property, right? So that was our last test, covered that stuff. Okay, but what if you can't find magic numbers, or it's hard to factor and you don't want to take the time to do it? There is another possibility that always works: the quadratic formula. It works in every situation. It'll even work in those situations where you're able to isolate x. You could use the quadratic formula there too. It's just easier to isolate x though, but it works in all situations. So why wouldn't we always use it? Well, sometimes the other methods are a little bit easier, because this is the quadratic formula right here. Once we've got our quadratic equation written in standard form, we would just plug in the values of a, b, and c and simplify. Okay, and so, but there's a little bit of work involved because I've got square roots in that. It's not like it's terrible, but there's a little bit of work involved, and sometimes it's just much easier to use one of the other methods. Okay, but today we're going to look at at the final outcome. What if the other methods don't work or they're too hard to do? Okay. Then we're going to use this. Now, one other little point though with the quadratic formula. The quadratic formula, it is much, much easier to use if we make sure that a is positive. Okay, so we want to always make sure that the leading coefficient, the coefficient of x squared, is positive. So what would we do in a situation like this situation up here in the purple box? I'm going to give you one quick example. What if I put a quadratic equation into standard form and I got negative 2x squared minus x plus 3 equals 0? So it's set equal to 0. It's in standard form, but a is negative, right? A is negative 2. Yeah, okay. The simple algebra step that we could use to make a positive would just be to multiply both sides of the equation by -1. In other words, I'm just going to distribute a -1 through everything, right? So what's that look like? Well, if I do that, if I distribute a -1, oh, come on. That's going to give me, my first term is going to become positive. My next term is going to become positive. The 3 is going to become negative. And -1 times 0, anything times 0 is just stays 0, right? So there we'd get it, we'd rewrite the quadratic equation where a is positive now. Okay, give me thumbs. That makes sense? Okay, once we get it there though, then all we have to do is just plug and chug into the quadratic formula. That's it, okay? So what about this first one then? What do I have to do? I've got y's instead of x's, but who cares, right? Same thing. Doesn't matter what the variable is. Could be x's, could be y's, could be z's, who knows? What do I have to do first here? In order to be able to use the quadratic formula, what were my first 2 steps? Well, I got to get it into standard form, right? Where a is positive. So how am I going to do that? What would I do algebraically? I've got to get it set equal to 0, but I want a, which is the number multiplied by x squared, or y squared in this case, to be positive. Yeah, just add the 8y to both sides, right? Okay, so first step. So those guys cancel. I get 4y squared plus 3 plus 8y. Well, I can't add any of those terms up, can I? Because 8y doesn't add with 4y squared or with 3. They're not like terms because in this case, the variable is being squared. In this case, it's not, right? Better give me thumbs on that. Does that make sense? Okay. So I end up on the right side, if I put it into standard form, I'm going to get 4y squared. Next comes the y term, so plus 8y plus 3 equals 0. It's in standard form. Okay. Now what? Well, now, I mean, in the past, we would have maybe tried to find magic numbers that multiply to, we'd have to use slip and slide. Are you guys really missing slip and slide a whole bunch, or you're anxious to go back and do some more? I didn't think so. So let's not. Let's just use the quadratic formula, right? So what are the values of A, B, and C? Carson, what are the values of A, B, and C? 4, 8, and 3. Good. 4, 8, and 3. Now I'm just going to plug those into the quadratic formula, right? And then just plug and check. Plug them in and then simplify. Every time it's the same thing, right? So we're going to get x equals, or actually it's y equals this time, right? So we're going to get y equals negative b. You guys tell me the values I'm plugging in. What's negative b? Negative 8 plus or minus the square root of 8 squared, good, minus 4 times, good, times 3, okay. All divided by, notice the division bar goes underneath the whole thing, all divided by 2 times 4. See, now all I have to do now is just simplify that, okay, using all the stuff we've done in Unit 4. So y equals negative 8 plus or minus the square root of 8 squared is 64. 4 times 4 is 16 times 3 is 48. So I'm subtracting 48. You'll have a calculator available on test. All divided by 2 times 8, or 2 times 4 is 8, right? So what's next? Well, I could figure out what's under the radical. So I get negative 8 plus or minus the square root of 64 minus 48 is just 16, all divided by 8. Square root of 16 is 4. So my answers then are negative 8 plus or minus 4, all divided by 8. So I just have to figure out, well, what am I going to get? I don't have to split this fraction up, do I? Because I'm going to end up on the top. I'm able to figure out what the outcomes are if I use the plus sign or the minus sign. I could do that really easily, right? Yeah, good. If I take the plus sign, I get y equals negative 8 plus 4. Well, that's just negative 4 divided by 8 on the bottom. That's just negative 1/2, right? So there's one solution. Okay, what if I take the minus sign? Then I'm going to get y equals negative 8 minus 4. That's just negative 12, right? Divided by 8 on the bottom. Well, that's negative. I get negative over positive is negative, and 12 over 8 just reduces to 3/2, right? So negative 3/2. Okay, everybody see that? Give me thumbs. Okay. What about this one? Can I isolate x here? I cannot, right? Because I can't point to a single x. There's 2 of them there. So, okay, good. So I see, notice he's doing this. That's a universal sign for distribute. Okay, we're going to have to put this into standard form, get it set equal to 0, right? But in order to do that, I'm going to have to multiply all this stuff out. So I'll distribute the x, and that's going to give me x squared minus 5x. I'm going to distribute the 1. That's going to give me plus x minus 5 equals 2. Well, if I combine like terms, I'm going to get x squared minus 4x minus 5 equals 2. Last step? Yeah, subtract 2. Good. Subtract 2 from both sides. and I get x squared minus 4x minus 7 equals 0, right? And now we just need the quadratic formula, okay? You don't want to have to be looking that up every time, so we're going to take just a second, and you guys are going to memorize it. Here's how you're going to memorize it. You ever notice, like, conservatively, how many song lyrics do you think you have memorized? I mean, if you really thought about it, it'd be like hundreds of songs probably, right? Don't you think? Did you ever really sit down and try to do that? Yeah, you just listen to it. And there's the science of the brain tells us that if you combine sounds like music with, with information, it's just easy to organize it, right? So that's, as annoying as this is, I still have students come back, that I see years and years later, and they can't, this thing is still stuck in their head. So I apologize in advance because it's going to be stuck in your head, but then you'll know the quadratic formula. Hi, boys and girls. Are you ready to learn the quadratic formula, son? Heck yeah, right? X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Isn't this fun? This is great. Let's try it again. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Let's do that again. Let's try and make it a little bit different. I don't know. Make it a little rockish. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Cool. Maybe we could sing it a little bit faster. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. That was fun. Let's try it a little bit slower. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Oh, that was so nice. So sweet. Let's just sing it one more time. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Divided by 2a. Okay, I'm not gonna make you listen to the whole thing again, but I want to end with this part right here because it's written properly here. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Yeah, I like that part because it's all written. It's written properly where the division bars underneath the whole thing. So you think you got it? Can you get by without hearing it again, you think? Yeah, it'll be stuck there, I think. Okay. So let's put it to the test. Let's see if you really do have it. All right, so we got this thing written in standard form, right? So now the next step is, what are the values of A, B, and C? Muriel, what are the values of A, B, and C for this equation? Good. 1, -4, -7. Now, can you guys remember the quadratic formula? You need to tune up your singing voices a little bit here. Okay, what is it? Yeah, that was kind of monotone. Okay, right? We got it? If you're needing a little refresher on this, and that's going to be your excuse, but I know secretly you're all just really kind of probably wanting to see that video again. It is on Google Classroom. If you go to classwork, under course information, let's see. Oh, where is it? Supposed to be there. What? Okay, I'll put it there. So it's in period 2. I just didn't put it in period 4, but it'll be under course information and resources, quadratic formula song. You want to hear it again. There it is. Okay, so now we have to just plug and chug. We've got the formula, quadratic formula. We've got the values. Let's plug this stuff in. There is one little part of this that I want to pay attention to. So when I'm plugging all this stuff in, x equals, what's negative b going to be? In this case, positive 4 plus or minus the square root of what? Negative 4 squared. Okay, that's correct. What is negative 4 squared? 16, right? Okay, what's the danger of negative 4 squared? You got to make sure it's in the parentheses when you put it into a calculator, and people tend to forget that sometimes. So what's a good solution to this? Anytime, not just now, but anytime you're squaring a negative, what should you just do instead? Not have a negative, just square the positive, and then you'll never make that mistake, right? So we'll just square positive b. So we get 4 squared minus 4 times 1, which I won't even write, times negative 7, good, all divided by 2. 2 times 1, which is 2, right? Okay, notice here, inside, if I'm multiplying 2 negatives together, what's the outcome? Positive. So I'm just going to do that. Okay, so I don't make that mistake either. Okay, and we get 4 plus or minus the square root of 16 plus 28 divided by 2, which is 4 plus or minus the square root of 44 divided by 2. So now I just need to figure out what the square root of 44 is using factor tree and couples go out, singles stay in, right? So let's do that part. What should I put right there for sure? What should my first number be? 11 and 4. And I'm going to put the 4 first. I want to put the one that's the perfect square first. And I picked 4. How come? Yeah, it splits into a couple of 2's, right? And then I'm stuck with a single 11. So my answer then looks like x equals 4 plus or minus. If I have a couple of 2's, what goes out front? 2, just a single 2. I mean, I don't use the word single. If I have a couple of 2's, whatever I have a couple of, that number by itself, not 2 of them, just one of them, goes out front. And then inside, I've got my single 11, and it's all divided by 2. Okay, so those are technically both of my solutions. Okay, this is a little different, though, than the last one. In the last case, I didn't have any square roots, so I could just figure out, I could just simplify this down to a fraction pretty easily, couldn't I? I could take the plus sign or the minus sign separately, and the numbers on top added together nicely and easily, right? They were like terms, okay? Not the case in this current example, because I've got a square root here, and I don't have a square root there, right? So those numbers are not going to combine nicely. 4 plus or minus 2 times the square root of 11, I can't do anything. They don't add or subtract. So when that happens, the best thing to do, remember we talked about this earlier in this unit, is to split that denominator up and make 2 separate fractions. So then I can reduce each one more easily, Okay, give me thumbs on that concept. How are we doing on that? Okay. So rather than having a common denominator, all that means is I'm going to write this 2 underneath both parts of the fraction separately. So I'm going to get 4 over 2 plus or minus 2 times the square root of 11 over 2. Okay, does that help? Seeing it that way? Now we can simplify both of those separately, and they're easier to simplify. 4 over 2 reduces to what? 2. Okay, what about this one? 2 times the square root of 11 over 2. What can I do there? Okay, well, you guys, don't make it harder than it is. Yeah, I can just cancel the 2's. Okay, and I just get the square root of 11. But I want to make sure you understand why. So I'm going to take just a second. So those are my 2 solutions. But how am I able to do that? Well, here's why. You know that if I have 2x divided by 2, I can cancel the 2's, right? That works. Those guys cancel. But if I had something like 2 plus x over 2, I can't cancel them there, right? What's the difference? Well, in this case, the 2 is not a factor in the top. It's not being multiplied by anything. It has to be multiplied by a bunch of other stuff or by other stuff in order for me to be able to cancel it. You can only cancel like factors vertically, right? 2 divided by 2 is equal to 1. Here I can't do it though, because that 2 is being added on the top, and this is not equal to x. I'll prove it to you. What if x is 3? 2 plus 3 is 5 over 2. 5 over 2 is not 3, is it? 5 over 2 is 2.5. Well, that's not what this says, right? This would say that if I canceled the 2's, I would just get 3, which is the wrong answer. So you can't cancel when you're adding, only when you're multiplying, right? And I'm multiplying here just like I am here. In this case, 2 is being multiplied by x, and here it's being multiplied by a square root, but it's still being multiplied, so I can cancel it. Okay, give me thumbs. Okay, I know that's like a really old concept, but sometimes people forget that from earlier years. So I just wanted to reinforce that. So those are both of my 2 solutions. Now, this is on the test too. What do I call, well, no, never mind. I'm jumping ahead. Okay, what about this one? Got to add the 1, don't I? Because I've got to get it into standard form, okay? So that's going to give me 4x squared plus 3x plus 1. And let's put the 0 on the right side this time. Make it look a little better. All right, it's in standard form. A is positive. We're not going to even try to factor that because it'd be slip and slide, right? So we're just going to use the quadratic formula. What are my values of A, B, and C? 4, 3, and 1. And let's remind me about the quadratic formula. Okay, you need to warm up your voices a little bit this time. X equals, come on. There you go. Okay, yeah. You know, it's funny. People are always, every year, like people are pretty, I think it's not very many people are in here. Because like when it's full class, people are really, the whole class ends up just singing it. But when there's only a few people, it's a little more, and it could be that's the end of the year and everybody's tired too. That's possible. End of a long year. So we got our stuff, right? Now we just have to plug and chug. So we know what A, B, and C are. So we can just plug stuff in. So we get negative B, that's just negative 3, right? Plus or minus the square root of 3 squared, we'll just write that as a 9, minus 4 times 1, that's just minus 16, agreed? All divided by 2 times A, that's just 8, 2 times 4. So there are answers, but we got to simplify. Negative 3 plus or minus the square root of 9 minus 16 is negative 7, all divided by 8. right? Well, I'm not going to get, this square root is not going away, is it? Everybody agree? So we're going to split this fraction up, right? Because I'm not going to be able to add this stuff on the top. So we'll split up the fraction, and I'm going to get a negative 3/8 plus or minus the square root of negative 7 divided by my common denominator 8. Let me do this. Maybe this will, you know how I am. I like to color code this stuff to, oops. Oh man, come on. Here we go. So I split the denominator. So there's my 8 right after I split it. Okay. What's the only thing left I have to do? What happens if I have a negative number inside a radical? That's giving me an I, isn't it? Right? That's giving me an I outside the radical. So I'm getting negative 3/8 plus or minus the square root of positive 7/8 times I. Make sense? Okay, that's good. This is the way we want to write it, because when we end up with complex numbers, we always want to write those complex numbers in standard form, right? And a complex number in standard form is just the real part plus the imaginary part times I, right? Everybody see that? So look what we get. We get, what's the real part of that solution? What's the imaginary part? Square root of 7/8. Give me thumbs. Does that make sense? Okay. How about that one? I'm covering up the plus now. I can't really get around there and do it, but what's that one? Negative 3/8. What's the imaginary part this time? Negative square root of 7/8, right? Okay, what do we call those? And this is on the test. What do we call answers like that are in the form A plus or minus B times I? Complex conjugates. There it is, complex conjugates. Okay, those are complex conjugates. It turns out, we didn't really get to this part of the next unit, but I'll mention it now. It turns out that anytime you solve a quadratic equation, if you're going to get i's in it, you always get a pair of i's. They always come in the form of complex conjugates. There's no other way it could possibly turn out. That you could never get a single I solution by itself. They always come in pairs, and the pairs are always complex conjugates. Okay? I think I probably mentioned that before, but I'm just saying it again, right? Give me thumbs on this one. Okay? All right, let's skip that guy. And the last thing I want to show you, when are we out of here? How much? 10 minutes? That's enough. Okay. So last thing I want to show you. There's something you can do with the quadratic formula that's kind of tricky. The part under the square root in the quadratic formula, the b squared minus 4ac, we call the discriminant. Okay, we call it the discriminant because it's able to discriminate between the different kinds of outcomes you're going to get. Am I going to get real solutions? Am I going to get imaginary solutions? What's going on? Well, think about how we would get imaginary solutions. The only way we get imaginary solutions is if I get a negative number under the radical, right? Make sense? So if the discriminant, if b squared minus 4ac is negative, we know what's going to happen. I'm going to get two imaginary solutions and no real solutions. I'm getting i's because I got a negative number under the radical. Okay, well, on the other hand, if we get a positive answer underneath the radical, there's no i's, right? We're getting real solutions. They're not imaginary. And I'm getting two of them, one for the plus and one for the minus. So if the discriminant is positive, if it's greater than 0, we get two real solutions and no imaginary solutions. Okay, what about the in-between, though? What about in between positive and negative is 0? What if the discriminant happens to be exactly 0? Then think what happens. I get x equals negative b plus or minus the square root of 0, which is just 0. What's negative b plus or minus 0? Isn't that the same thing? Adding and subtracting 0 gives me the same answer, right? I just get negative b on the top. So I get negative b over 2a. I only get one answer. I don't get two. The plus and the minus give me the same thing. And so if the discriminant is exactly equal to 0, I just get one real solution and no imaginaries. Okay? We could do one more. Now on the test, that's all I care about. On the test, the only questions I'm going to ask are the number of real solutions or imaginary solutions. That's it. Okay. On the homework, I do one more little thing. It just goes into a little bit more depth. So what if the discriminant is a perfect square, like in our first example? Right, in our first example, we got the square root of 16. That's a perfect square. And so the square root went away. And I just ended up getting two different fractions, no square roots. Well, if I just get fractions, that's the definition of a rational number. Ratio means fraction, right? A rational number is any number that can be written as a fraction. And if the square root goes away, I'm getting fractions. So one thing we know is that if the discriminant is a perfect square, our real solutions are actually going to be rational numbers, right? So the real solutions, we could be more specific and say they're also going to be rational numbers. If it's not a perfect square, like we got in our second example, well, then we got stuck. We had square root of 44, right, which is not a perfect square. We got stuck with square roots in our answer. So you can't write those as fractions, right? The square roots make it irrational. So if the discriminant is not a perfect square, our real solutions are irrational real numbers, okay? So let's just try to practice this a little bit. First, let's review. So what is the discriminant? We'll call it little d. It's the part under the square root in the quadratic formula, and you guys all know that, right? So what is the discriminant then? B squared minus 4ac, good. And if it's greater than 0, so both of these two cases, if the discriminant's positive, how many solutions am I getting? 2. And they're real, aren't they? Right? I'm getting 2 real. But we can be a little more specific. If the discriminant is a perfect square, what kind of real solutions are they? Rational, right? I'm going to get fractions. I'm not going to get any square roots in my answer. So they're real and they're rational. If it's not a perfect square, then the square root is not going away. So my real solutions are going to be what? Irrational. Okay, if d is exactly equal to 0, how many solutions am I getting? 1. Real. And not that I'm going to test you on this, but it's actually if the square root part goes away, because the square root of 0 is 0, it's a rational solution, isn't it? And then the very last one, if d is less than 0, I'm getting 2. See, Muriel? I'm getting 2 what kind of solutions? Imaginary. Okay, so let's try a couple quick sample problems. So what about this? We got to calculate the value of the discriminant, and that's just b squared minus 4ac, right? So I'm going to get negative 24 squared, but I'll just square the positive. 24 squared minus 4 times 1 times 144. Well, if you do the math, that's going to give me 576 minus 576. What's that? 0. Okay, so what's the correct answer then? You guys pick. A, B, C, or D? There you go. One distinct real solution. And it's rational, right? Okay. So how about this one? What do I have to do first here? Okay, I got to put it in standard form. So I got to move these guys over there, right? To the other side. So that's going to give me 2x squared plus 8x minus 7 equals 0. So then I calculate my discriminant, b squared minus 4ac. That's giving me 8 squared minus 4 times 2 times negative 7. Negative times negative is positive. And so what's that giving me? 64 plus 8 times 7 is 56. 120. Is that a perfect square? 120? So what am I going to get then? Real irrational. Good. So it would be A, wouldn't it? Okay, on the test though, I don't care if they're rational or irrational. It would just be two reals, right? Okay. How about this one? Well, what are we going to get here? B squared minus 4ac is going to give me 7 squared minus 4 times 5 times 14. So that's 49 minus 280. So that's negative 231. You guys will have a calculator. I'm just trying to go really fast here so we get through all this stuff. So it's negative. What am I going to get? Okay, so which answer then? Okay, which one of those fits though? B. There you go. Imaginary is the same as non-real complex, right? And then this guy. That's going to give me 5 squared minus 4 times 1. So that gives me 25 minus 16 is 9. So if the discriminant is 9, okay, those are rational because that is a perfect square. It's positive, so we get two reals. That's a perfect square. So it's got to be real and rational. So it's A. Okay, last one. So here's the important thing to remember. We've talked about this before. Only real zeros correspond to x-intercepts. Imaginary zeros do not show up as x-intercepts, right? So on this one, I like this one better in a way because you don't even have to calculate the value of the discriminant. You just need the sign. B squared minus 4ac is 6 squared minus 4 times 3 times 4. Well, that's negative, isn't it? 36 minus 48. Right? So I don't even need to know what the number is, but I do know that it's negative. If it's negative, does it have any real zeros? If the discriminant's negative? No, I'm getting imaginary, right? So how many x-intercepts does it have then? None, right? Because it has no real zeros. Man, that's timing. How about that? Okay, you got the rest of the time to just finish stuff up. I'll put up this last test. On the last test, I'll tell you what I'm going to do. I'm going to let you, because we're running out of time, I'm going to let you guys do this either in class or at home. I don't care. Okay? So it's up there and ready to go. You betcha. I'll see you.